The particle of mass m each are tied at the ends of a string of length 2l. Now the ends of the string, now this is 2a, so the half part will be equal to a and the other half will be equal to a. Okay, is kept on a frictionless horizontal table with the strings tied so tight that each distance will be equal to a from the center point P as shown in the figure. Now the midpoint of the string is pulled vertically upwards. Now this is pulled vertically upwards with a small but constant force F. As a result, the particles move towards each other on the surface. Okay, the magnitude of the acceleration when the separation between them is 2x will be equal to. Now understand that when I try to pull it upwards, after a certain time what will happen over here? The two masses will look somewhat like this, okay, and the separation between them is 2x, so individual distance over here is equal to x. Now we have to calculate the magnitude of the acceleration when the separation between them is equal to x. We have to calculate the total acceleration of the blocks. Now the 2f, if I consider this point, let this tension be equal to t, then this tension will also be equal to t, correct? If the tension on the left hand side, if it is equal to t, on the right hand side it will also be equal to t, because over here both the masses are same. Let the angle over here be equal to theta. So now over here the tension on the mass, consider any mass, if I draw the FBD of this mass, if I draw the free body diagram of this mass, it will look somewhat like this. The mass is over here, the angle is theta, this distance is x, this distance, now the string is unstretchable, so this distance is equal to a over here. Okay, this distance is a over here, so we have to calculate the acceleration of the block. In this case I will write the acceleration block as capital A instead of small a to avoid the confusion. Now the tension over here, let it be equal to T. So basically if it is equal to T, so F will be equal to, the total force will be equal to, if I draw let me say the center point over here is O. So if I draw over here, the force is in this direction, the tension is making, the tension theta is making an angle theta over here, another tension T is making an angle theta over here. So I can say that F will be equal to, when I consider the first diagram, F will be equal to 2t cos theta. Basically F will be equal to 2t cos theta. Okay, let this be the first equation, we will use this later. Now let me see for this mass, any individual mass. Okay, so T, it will be equal to the total tension in cos theta. The total tension in cos theta will be, the cos theta, the T cos theta will be in this direction. Let it be the horizontal acceleration, which I write it as ax. Okay, and the T sin theta will be equal to, the T sin theta, the T cos theta will be equal to ax, and the T sin theta will be equal to ay. Okay, that is the acceleration, or m into ay. Okay, m into ax and m into ay, where over here ay is the acceleration along the y axis. I am consider this as the y and this as the x axis as the standard axis over here. So basically I want to calculate the total acceleration, so I have to square and add that part. So T cos theta is equal to max and T sin theta will be equal to may. I want to calculate the total acceleration, so basically it will be equal to, if I square and add this part, it will be equal to m square a square x plus ay square, okay, is equal to sin square theta plus cos square theta over here. Okay, now I want to find out the total acceleration. So total acceleration in terms into t square over here. Okay, sin square theta plus cos square theta into t square over here. Okay, so now m square a square plus ax square plus ay square will give me the total acceleration. Let it be equal to a square, sin square theta plus cos square theta is equal to 1, so it will be simply equal to t square. So m square a square, instead of t square what will I substitute? F divided by 2 cos theta the whole square. Okay, f divided by 2 cos theta divided by whole square. Now cos theta, if you consider, it is this length okay, if the center is O, this point is A over here, so this is this length, okay, let me say whatever is the length, if you can calculate the length over here, this is A, this is X, so this length over here will be equal to A square minus X square, okay. So cos theta over here is equal to A square minus X square. So over here, first of all, I will take the root of this part. So A will be equal to, F divided by 2 cos theta into M, okay, or 2M cos theta. So if I write down the value of cos theta over here, it will be equal to adjacent upon hypotenuse. Adjacent over here is given as, which is equal to F divided by 2M. Adjacent is given as root of A square minus X square into hypotenuse. Hypotenuse is given as A, so A will go in the numerator. So it will be equal to, if I calculate the value, it will be equal to F divided by 2M, which is in all the 4 options, into A divided by root of A square minus X square, so which is option number A, okay. So for this question, the answer is option number A.